This is Mambeth and today I am your math teacher. Before we proceed in the discussion of the first lesson in the first quarter of grade 9, let's have an activity first. This activity is entitled, Do you remember these products? In this activity, you're going to find the product in each expressions. We have three expressions in this activity. First, we have 3 multiplied by x squared plus 7, followed by 2s multiplied by s minus 4, and the third one is w plus 7 multiplied by w plus 3. You may pause this video so that you will be having more time to answer the given expressions. And then after answering the given expressions, you may now play the video again. Are you ready, learners? Happy answering! And you're back! Let us check if your answers are correct. Let's have first the first expression. We have 3 multiplied by x squared plus 7. The correct answer is 3x squared plus 21. How come? By doing or applying the distributive property of multiplication, we're going to multiply 3 to the first term of our binomial. We have 3 multiplied by x squared, which is 3x squared. And then multiply 3 to the second term of our binomial, which is 7. So 3 multiplied by 7, we have 21. Therefore, the correct answer is 3x squared plus 21. Let's have the second expression. We have 2s multiplied by s minus 4. The correct answer is 2s squared minus 8s. Same process on what we did in the first expression. Multiply 2s to s, we have 2s squared. And then 2s multiplied by negative 4, we have negative 8s. Therefore, the correct answer is 2s squared minus 8s. Let's have the third expression. The third expression is w plus 7 multiplied by w plus 3. In this expression, what we are going to use is the FOIL method. To simplify, we will have this equation or expression. W squared plus 3w plus 7w plus 21. How come? By multiplying the first terms of the two binomial, we will have w times w, which is w squared. And then, multiply the outer term of the two binomials, which are w multiplied by 3, and that is 3w. And then, multiply the inner term of the binomials. We have 7 multiplied by w, which is 7w. And for the last, we're going to multiply the last term of the two binomials. And then, that is 7 multiplied by 3, which is 21. After that, we're going to combine like terms. The like terms in this expression is 3w and 7w. Therefore, we will be having 10w. And the correct answer is w squared plus 10w plus 21. And as you can see, these are the answers or the products of the given expression in the activity. We have 3x squared plus 21, 2s squared minus 8s, w squared plus 10w plus 21, and those are what we call the quadratic equations. And quadratic equations is our topic for today. So let's first define quadratic equations. A quadratic equation is an equation where the variable is of the second degree. As you can see in the left side of our video, we have here an example of quadratic equations. We have 3x squared plus 21. When we say second degree, meaning the highest exponent in the given expression should be 2. As you can see, the highest exponent in 3x squared plus 21 is 2. How about 2s squared minus 8s? The highest exponent in this expression is also 2. For the third one, we have w squared plus 10w plus 21, and the highest exponent is also 2. And for the fourth example, we have x squared plus 7x minus 18, and the highest exponent is also 2. And for the last example, we have 2t squared plus 9t minus 5, and the highest degree is 2. Therefore, the examples in the left side is what we call the quadratic equations. And always remember the standard form of the quadratic equation, which is ax squared plus bx plus c is equal to 0. So let us name the parts of the quadratic equations. We have ax squared, that is our quadratic term. We have bx, which is our linear term. We also have c, which is our constant term. Always remember those three parts of the quadratic equations. Let's have an example. We are going to do is to determine which of these are quadratic equations. Is c is equal to 2 pi r a quadratic equation?
Try again.
No, that is not a quadratic equation because we don't have an exponent of 2. How about x squared minus 2x plus 1 is equal to 0? Correct! That is an example of quadratic equation because as you can see, the highest exponent is 2. How about a is equal to pi r squared? Correct! That is also an example of a quadratic equation because the highest exponent is 2. How about 2x squared minus 5x plus 1 is equal to 0? Correct! And as you can see, the highest example, or the highest exponent rather, is also 2. How about x plus 3x is equal to 0? Try again, because that is not an example of a quadratic equation. Because as you can see, 2 is not the highest exponent in this expression or equation. We also have 3x squared minus 5 is equal to 0. Is that a quadratic equation? Correct! That is an example of a quadratic equation because 2 is the highest exponent. Which among the quadratic equations below are complete and incomplete? When we say complete, meaning our quadratic term, linear term, and constant term are given. And for the incomplete quadratic equation, either of the three is missing. So let's identify if the first expression is a complete quadratic equation or not. Let's have 4x squared plus 7x is equal to 5. What we are going to do first is to transform the quadratic equation into standard form, which is x squared plus bx plus c is equal to 0. What we are going to do first is to transpose 5 to the left side of the quadratic equation. Therefore, we will be having 4x squared plus 7x minus 5 because as you can see, we transpose the 5 into the left side of our equation. Therefore, that is the standard form of the equation. And then after that, we may now find for the value of a, b, and c. For the value of a, the constant number in the quadratic term is our value of a. And for the value of b, the constant number in our linear term is the value of b. And for the value of c, the constant term is as it is. So let's find the value of a. The value of a in this expression or equation rather is 4. As you can see, the constant number in the quadratic term is 4. How about for the value of b? The value of b is 7. As you can see, the constant number in the linear term is 7. And for the value of c, we have negative 5. Because as you can see, the constant term is negative 5. So let's have another example. We have 3x squared is equal to negative 7. Is that a complete quadratic equation or not? What we're going to do is to transform that in the standard form. We're going to transpose negative 7 to the left side of the equation, which will be having 3x squared plus 7 is equal to 0. And then after that, we're going to have or to find the value of a, b, and c. The value of a in that equation is 3. And the value of b is 0. Why? Because as you can see, we don't have a linear term. Therefore, the value of b is 0. And for the value of c, we have 7. Let's have another example. We have 2x plus 5 multiplied by x minus 1 is equal to negative 6. What we are going to do first is to simplify the equation. By using or applying the FOIL method, we're going to simplify it. So what we will have is 2x squared minus 2x plus 5x minus 5 is equal to negative 6. How come? By multiplying 2x to x, we have 2x squared. 2x multiplied by negative 1, we have negative 2x. 5 multiplied by x, we have 5x. And then 5 multiplied by negative 1, we have negative 5. And then, what we're going to do next is to transpose negative 6 to the left side of our equation. So from negative 6, it will become positive 6. And then after that, as you can see, we have here negative 2x and 5x. We're going to combine like term. And then, so negative 2x plus 5x, that is positive 3x. And as you can see, we may combine negative 5 and positive 6. And it can be resolved to positive 1. Therefore, 2x squared plus 3x plus 1 is equal to 0 is the standard form of the quadratic equation. And then, we may now find the value of a, b, and c. So the value of a in the quadratic equation is 2, while the value of b is 3, and the value of c is 1. And those are the examples in quadratic equation and how to transform